We will start now with the fourth section of this chapter, which is fractional distillation and paper chromatography. In the previous section, we have been introduced to simple distillation, and we used simple distillation to separate water from a salt solution. So we collected the solvent, which is water, from the NaCl solution. Actually, distillation can be used as well to separate miscible liquids such as ethanol and water. Ethanol and water mix completely and are dissolved in each other. They will not form separate layers as the ones we see of immiscible liquids such as oil and water. So as you can see, oil and water here form two layers. However, if we mixed ethanol and water, we will have a solution of one phase only. So those miscible liquids, such as ethanol and water, have different boiling points. And this difference in the boiling points can be utilized to distill off and collect the liquid with the low boiling point first. However, if these liquids have similar yet different boiling points, like for example 80 and 100 degrees Celsius, it will be hard to get pure liquids by simple distillation. The reason is that vapor is given off from each liquid before actually reaching the boiling point. So, to enhance separation, a fractionating column, which is a tall glass column filled with glass beads, is added to the apparatus of distillation, and it is fitted vertically on top of the flask being heated, as you can see here. So this is the fractionating column, which will enhance separation, and now we will see how. So let's take a look now at what happens in a fractional distillation to be able to figure out the difference between simple and fractional distillation. You will place your mixture of liquids here in this flask, which is called the distilling flask, and you will start heating until boiling. And as we have said, we will add a fractionating column, which is filled with glass beads, as you can see here. As we heat, the temperature will rise, and thus liquids will start to change to vapors. The vapor now must pass over and between the glass beads in the fractionating column before they reach the condenser. The temperature in the fractionating column is highest at the bottom and gets lower as the vapor rises up. Then, the substance with the higher boiling point will condense more readily on the cooler beads nearer the bottom of the column, and then they will drop back down into the flask beneath. On the other hand, the substance with lower boiling point will continue rising and will pass over into the condenser, where it is cool enough to turn back into the liquid state. So remember, the cold water circulating around this glass tube of the condenser, which contains the vapor, will lower the temperature of this vapor, and thus it will condense back and it will be collected as a liquid in this receiving flask. And the liquid which is collected in the receiving flask is called distillate. So let's take an example. We are now interested in separating ethanol and water, and we need to collect ethanol. The boiling point of ethanol is 78 degrees Celsius and that of water is 100 degrees Celsius. So we will read the temperature from the thermometer, which is placed here. If the temperature reading on the thermometer can be kept around 80 degrees Celsius, then the liquid collected will be mainly ethanol, because water boils at 100 degrees and thus there's still a difference between the temperature inside the flask and the boiling point of water. But of course, we need to make sure that this is really ethanol and not a mixture of ethanol and water. So to check if there is a difference between the starting mixture of ethanol and water and the distillate collected, you can apply a lighted splint to a small volume of each in an evaporating dish. So you will put in the first evaporating dish a sample of the distillate that you have collected, and in another one a sample of your starting material, which is the mixture. Ethanol is a flammable liquid. However, it's not flammable if it's mixed with an excess of water. And then, because the distillate is ethanol only, it will ignite and burn with a clear blue flame. So if you were able to see the blue flame, this means that the distillate you have collected is a pure ethanol. Fractional distillation is used in industry. For example, fractional distillation is used to separate ethanol from a fermented mixture in the alcoholic spirits industry and in the use of ethanol as a biofuel.